Welcome, beginner game developers, to an in-depth tutorial on the Singleton game design pattern, a fundamental concept for managing global resources in Unity. The Singleton pattern ensures a class has only one instance and provides a global point of access, crucial for coordinating actions across your game system. This pattern is incredibly useful for managing game states, audio, UI elements, and other global resources that should exist uniquely. At its core, a singleton restricts the instantiation of a class to one single instance, preventing multiple copies from existing simultaneously. Its primary purpose is to ensure only one instance of a class exists and to provide a global access point to that specific instance. This makes it ideal for central management of game resources and services, streamlining how different parts of your game interact with core systems. Let's dive into implementing a singleton in Unity using C#. First, create a new C# script in your Unity project. Inside this script, declare a private static variable of the class type to hold your single instance. Next, create a public static property, often named instance, which will provide global access to this unique instance. In the awake method, implement logic to check if an instance already exists. If it does, destroy the new game object to prevent duplicates. If no instance exists, set the current instance to this and use don't destroy on load to ensure it persists across scene changes. Here's the complete code for a basic singleton implementation in Unity, combining all these elements. To use your singleton, simply access its instance from any other script using singleton. Instance followed by the method or property you need. Common use cases include a game manager to oversee overall game state, like score or level progression. An audio manager can control and play all audio throughout your game, ensuring consistent sound management. A UI manager effectively manages UI elements and switches between different UI panels, centralizing your user interface logic. Finally, a save system can handle all game saving and loading functionalities, providing a single point of contact for data persistence. One major advantage is global access, providing an easy and consistent way to reach a central point of control from anywhere in your code. It also offers controlled instantiation, preventing multiple instances of critical managers that should only exist once. Singletons are excellent for resource management, especially for shared resources like object pools or configuration settings. Furthermore, they enable data persistence, allowing data to carry from scene to scene without complex saving and loading mechanisms. However, singletons can lead to tight coupling, making your code harder to maintain and test due to direct dependencies. Testing can become more complex because global state makes unit testing individual components challenging. Overusing singletons can create God objects that handle too many responsibilities, violating the single responsibility principle. They can also hide dependencies, making it less clear which classes rely on the singleton without inspecting the code. To use singletons effectively, use them sparingly, only for truly global systems that genuinely require a single instance. Avoid storing scene-specific data within singletons, as this can lead to unexpected behavior when scenes change. Consider alternatives like dependency injection or scriptable objects for managing dependencies and shared data more flexibly. Always ensure your singleton has a clear and specific purpose, adhering to the single responsibility principle. Dependency injection involves passing dependencies explicitly to classes, making them easier to test and manage. Scriptable objects are excellent for shared data and game settings, providing a data-driven approach without global access points. Static classes can be an alternative, but unlike singletons, they cannot be destroyed or disposed of, and their state persists throughout the application's lifetime. One common pitfall is memory leaks if you forget to properly clean up the singleton instance, especially if it holds references to other objects. Circular dependencies can also arise, making debugging incredibly difficult when two singletons unexpectedly rely on each other. Initialization order issues can occur if a singleton is accessed before it has been properly initialized, leading to null reference exceptions. To address duplicate prevention, our awake method check ensures only one instance survives, destroying any subsequent ones. For persistence across scenes, don't destroy on load is crucial, keeping your singleton active even after scene transitions. Lazy initialization, where the instance is created only when first accessed, can improve performance and prevent unnecessary object creation. For advanced implementation, consider a generic singleton to reduce code duplication across multiple manager classes. This generic approach allows any monobehavior class to easily become a singleton by simply inheriting from generic singleton T. While less critical in Unity, thread safety might be considered if your singleton is accessed from multiple threads simultaneously. Let's compare singletons with static classes. Singletons can have constructors, while static classes only have private static parameterless constructors. Singletons can be destroyed and disposed of, allowing for resource cleanup, whereas static classes persist for the application's lifetime. Singletons can be instantiated using the new keyword, offering more control over their creation, unlike static classes. Both are stored on the heap, but static classes reside in a special area not subject to garbage collection, impacting memory management. Singletons can implement dispose to release unmanaged resources, a capability not available to static classes. Static methods generally offer better performance due to compile time binding, while singletons can be lazy loaded for efficiency. The Singleton pattern is a powerful tool for game development when used judiciously, providing centralized control for critical systems. Remember to weigh its advantages against potential disadvantages and consider alternatives for a robust and maintainable game architecture.